Welcome students. Let us discuss some interesting laws of operations on sets. So we are already doing this chapter sets, and we have seen so many properties, so many laws, so many problems from this chapter sets, and our this new topic is laws of operations on set. So we will start with laws of union of sets. We'll start with laws of union of sets. You know, there are some operations on sets. As for example, union is a kind of operation on sets. Intersection is operation on sets. Similarly, complement is an operation on sets, isn't it? So let us see what are the laws of union of sets. So first law, which is A union B, this is equal to B union A. It doesn't matter that whether you make A union B or B union A. Means order of two sets while operating union on these two sets is immaterial. It doesn't matter. Okay. And this law, this property is known as commutative law. This is known as commutative law. Okay. So A union B is equal to B union A. Second, associative law, A union B union C is equal to A union B first and then union C. Okay. So what is the difference here in left hand side and right hand side? In left hand side there is a bracket in these two sets B and C. It means, as we know in elementary mathematics, that first of all we will make this operation B union C, and after making this operation complete you will again make this operation A union this one. Similarly, in the right hand side, first of all make this operation A union B, and then we will operate union C. Okay. This law is known as associative law. Third is laws of identity. Laws of identity means A union phi is equal to phi union A, and this is equal to A. This is known as laws of identity. Here phi is identity set with respect to the operation of union. Okay, with respect to the operation union, phi is called here identity set. Okay, so this is known as laws of identity. Fourth, when you operate A union with set A itself, this is equal to set A. This is known as law of idempotent. This is known as law of idempotent. Means when two sets are same and union of these two sets will be set itself. Okay. And finally, last law for union of sets, which is A union universal set, or by commutative law universal set union A is equal to universal set itself. Because we know that set A is a subset of universal set. A is a subset of universal set. That's why no another element is coming other than elements of universal set. Okay, so we can understand it more clearly. Suppose any set A is a subset of another set B, then A union B will be how much? This will be B, because B is the larger set and all the elements of A have been taken from set B. So definitely A union B, union means collection of elements. So collection of elements from A as well as B will set B itself. Similarly, in place of B, if you write here universal set, then A union universal set is equal to universal set is equal to A. This is equal to universal set. Okay, so this is all about laws of union of sets. Now let us discuss laws of intersection of sets. Laws of intersection of sets. Accordingly, we'll discuss these laws also. First is A intersection B is equal to B intersection A, and this is known as commutative law. This is known as commutative law. Like here union, in case of intersection also, order of sets A and B is not relevant here. It doesn't matter. It doesn't mean that whether A comes first or B comes first. It is immaterial. So A intersection B and B intersection A both are equal. And as we know, intersection means just we have to select common elements from these two sets A and B. So A intersection B is equal to B intersection A. This is known as commutative law. Okay. And second, associative law. A intersection B intersection C. Here B intersection C is bracket in left hand side, and this is equal to A intersection B is in bracket intersection C. So as we discussed here these two sets with this operation intersection are in bracket, but here first two sets under this intersection operation of intersection are inside the bracket. So it doesn't matter that which operation has been done first, whether B intersection C or A intersection B. This is known as associative law. Third, laws of identity. Okay, means here A intersection phi is equal to phi intersection A. This is equal to phi. Why phi? Because in this operation of intersection we have to select common elements from these two sets, but this null set empty set is having no element, so there is no question of having any common element of these two sets. So finally result is empty set here. That's why phi. Okay. And fourth, A intersection A itself is equal to A. And fifth, A intersection universal set is equal to universal set intersection A. This is equal to A, because A is subset of universal set. Here in this case, as we know, as A is a subset of universal set. A is a subset of universal set. So only those elements are common which are elements of set A here. Correct? So similarly, as we have discussed here also we can say that if A is subset of B, then A intersection B is equal to A, smaller set. A is subset of B, A intersection B is equal to set A. Only elements of set A are common here. So these are laws of intersection of sets. Now another is distributive law. Distributive law. In distributive law, we can write A union B intersection C. Here we have to be alert. We have to observe that B intersection C is inside this bracket, and before this bracket we are having A union B. So here union is outside the bracket. So this union will be distributed over both the sets B as well as C. That's why this is known as distributive law. So this is A union B intersection A union C. This A union has been distributed over both the sets B as well as C, and intersection is in between these two operations. Similarly, A intersection, if intersection is outside the bracket and here B union C, means simply here intersection and union, these two operations have been exchanged with each other. So right hand side also accordingly there will be exchange of these two operations, union and intersection. So here this intersection will be distributed over both the sets B and C. So this will be A intersection B union A intersection C, correct? So these are very basic and very simple laws of operations on sets. And finally, last, which is known as De Morgan's law. De Morgan's law. Here we'll have two laws. First is A union B whole complement is equal to A complement intersection B complement. So first of all, let us try to understand what is complement. Okay, what is complement of a set? Suppose set A is here, and you know what is universal set. So A complement, this is equal to universal set minus set A. This will be A complement. Okay. So this complement is being distributed over both the sets A and B, but this operation universal union is being converted into intersection. Similarly, the second law of De Morgan is A intersection B whole complement. Complement is denoted by this notation dash, or sometimes this is denoted by writing C also. Okay. So this is equal to A complement union B complement. This complement has been distributed over both the sets A and B, and this intersection sign has been changed to operation union of sets. Okay. So these are very basic and simple laws on operations of sets, and now we have to discuss some problems related to these laws on operations of sets. So please remain in touch with my videos. These videos will be very beneficial because I am trying to make your basic very clear, and trying to present all these things in a very interesting way, so that if you see these videos, you study one time, you can remember throughout it. Okay. So keep in touch with this video and enjoy learning mathematics. Thank you very much.